So, in this lesson we are going to learn about data structures, but before that two quick anecdotes. So in the last lesson we were talking about this program that I wrote, where we were just taking an input and then we were printing it right back, but I forgot one step, and so let's just run this to see what happens. So we just double click and it says please input your name. I do that and then it immediately closes. It actually printed that statement, but immediately it closed after that, so we didn't get a chance to read. So as I kind of mentioned, but I forgot to show this to you, so that's why the anecdote. So we need to pause the program. So to do that we actually use input again. By doing this, the program waits for an input from us. So here we can put something helpful like please press enter to close, because that's what is going to happen. So now if we save this and run it, you see that it prints how are you and then says press enter to close. Very helpful. We can read the message and then close it. Another point that I want to mention is something known as comment. So all of these things that we are writing here are understood and read by the Python interpreter, which is a program that I mentioned is the middleman between you and the computer. But there is a way to tell the Python interpreter to ignore certain lines, and these are known as comments. So there are two kinds of comments, and the first kind is just this is a single line comment. So any line that starts with an hash will have no effect on the program. Basically it will be ignored by the interpreter. So you can write whatever you want here and the program will run just the same. But the purpose of comment is not to clutter up your code, but to add helpful pointers to anyone who is reading your code, and also very importantly to yourself, because believe me, a year or two later you would have no idea what you are doing if you came back to a complicated piece of code. So it is very important that you comment your code appropriately, not too much, not too little. Explain where explanation is needed, and give your variable meaningful names, because the computer doesn't care. I can call this A and that will just work. It's fine, it doesn't matter as long as I call this A as well. But if I called this A, then if as the code volume increases, I will have no idea of what A means. So this is not a descriptive name. So please keep these two things in mind. They are very important. Give descriptive names to your variables and add comments wherever necessary. So for example, here I can add a comment describing what this program is doing. So user input and output, for example, something like that. You can put whatever you want, and I can run this and you can see that it works exactly the same way that it did before. No difference, but now your code is a little bit more easier to read. So remember I was showing you this demo code. There are actually a bunch of comments here that I just took out because it was looking a bit cluttered. But here you can see that my brother has actually added helpful comments to explain what these pieces of codes are doing. So for example, this piece of code is taking any number and divides it and then sends it to this piece of code here, and this piece of code is actually responsible for spelling out the numbers and so on. So it makes reading the code much easier. So between the helpful comments, the nice naming of the variables, and the easily readable Python syntax, Python codes are really nice to read. Okay, so anecdote is over. Now let's get into talking about data structures, what they are, what they mean, and so on. So for this I'll actually use idle for the entire demo. In fact, let me just full screen it. Oh, can I make this bigger or somehow? Let's see. Yes, I can. Otherwise these small fonts in a video would be very difficult to see indeed. So just to make that a bunch bigger. Hopefully it is a bit more clear now. So let's talk about data structures. So data structures are ways or methods. How do I put it? There is a technical definition of this. Of course, this is actually a technical term, data structure. In fact, there are courses you can. I think in ISF Bhopal itself there are courses on data structure and algorithms. These are foundational building blocks of computer science. But that aside, data structure is just a way to represent data inside your program. And Python has several data structures, data types, and I'll explain what I mean by that. So let's take a variable called let's say foo, and I'm calling it foo because this is kind of a what do you call, this is kind of a custom that there are two variables called foo and bar, and for demonstration purposes these are often used. So just as a custom I'm using them. So let's say foo is equal to 10, and now Python knows that there is something called foo, and that foo is equal to 10. Now I can ask Python that okay, what type of thing foo is. So as I was saying earlier that in Python everything is an object. So here what I am doing is asking Python what type of an object Python thinks foo is. So Python will tell me that it is an int, and int stands for integer. So any number that is not that doesn't have a decimal point on it is stored as an integer object or integer class, you can say. So Python stores these as integers. So integers is one type of data structure. Sorry. If we have a decimal point, so let's say foo is 10.5. Notice that I am reassigning foo. So now I am telling Python, okay, foo is now 10.5. So Python will forget that foo is 10, and Python will now remember that foo is 10.5. This is known as reassigning the variable. So now if I ask Python that what type of object foo is again, Python will say it is a float, and the name might sound funny. I thought it was funny when I first learned of it. The float stands for floating point integer, floating point value, I think. That has to do something with that is a long discussion in and of itself, why it is called a floating point value, but I'll not get into that. Just know that these are called floating, these are called floats, and so it can you can have as many decimal points as you like. So you can say foo is equal to 1.22345,123, and Python will say okay, I don't mind. And if you ask Python what foo is, Python will give you back that value. So these are the two numerical types that Python has built in. You can have other types of numerical values like doubles and whatnot, but those doesn't come built in. You have to get them from somewhere else. But that let's not make this complicated. So to make this very simple, there are two types of numerical data types. Ints and floats. Ints are just integer, so you know what they are. Basically they're just integers, and anything with a decimal point on it is a float. So let's reassign foo again to, let's say, 10, back to 10, and let's call bar now. So let's say bar is 3. So now I can divide foo by bar. So let's say result is equal to foo by bar. So now if we ask for result, then we get the value back, which is 3.33, which is in fact correct. But do you notice something? Do you see that it is 3333335? Where did that 5 come from? That's weird. I mean, mathematically it is just 3.33 recurring, right? So where did that 5 come? That's strange, isn't it? I mean, even if you round it up, it will just be 3.333, right? I mean, where did that 5 come from? Strange. That 5 is related to the thing that I was talking about with floating point value. Remember I was telling about that. So if you think for a minute, you will realize that this number 3.3333, this is infinite. The 3's go on infinitely, right? So the computer have to stop somewhere, and it has to represent that incompleteness in a way, and that is done using this floating point variable, and sometimes small inaccuracies arise because of that, and you can see one of that in action there. So I mean, in any kind of real calculation, this small of an error would not really matter, but sometimes strange things can actually happen because of this. So just be aware of that. This is called a floating point error. But anyway, we are digressing from our topic. So we were discussing different data types. So we have discussed integers and floats. Now let's look at another type of data, which is known as boolean. So let's get back our friend foo again. So let's say foo equals true. So you see that as soon as I type the word true with a capital T, it became orange, which means Python recognizes this word as a special thing. So if I do that and then ask what type of object it is again, you'll see that it says class bool. Bool is another type of data which represents boolean. It can just be true or false. It cannot be anything else. It's just true and false. So it's just a binary switch basically. It is useful in certain cases, although the concept of it is very, very simple. So let's move on. Next we will look at character data types. So now we can store numbers. How do we store characters? We store characters in data types called string. So let's say foo is equal to Python, and if we ask once again, you'll see that it says class string, str, which stands for string. And Python is so and now we can do various things with that string object that we made. So that's how Python stores string objects. That's that. And yeah, so these are a few basic data types. There are okay, hang on for a moment, I'm a bit let me think.